All right, getting started here. We're going to determine the domain of the function, and we're going to write your answers in interval notation. So what we've got to do here, well, we got a little glare there. Hope that's okay. What we're going to do is always factor it, right? Whenever you see a rational function, make sure you factor it. And if we look here, I do believe this is going to be, let's see, factors of 30 is going to be 6 and 5. Right, so we're going to have to factor it. So we got negative 30, and we're looking for 1, which is going to be 6 and negative 5. Okay, then we're going to divide these guys by 2 so that we get an x plus 3 and then a 2x minus 5. And then double check, we're going to get 6x, and then, okay, we get a negative 15. Perfect. Okay. Now this one's going to be a little easier. This one you can probably do mentally. You're going to get x negative 7 and then x positive 3. Okay, now all of this is really just pointing at the denominator. In the denominator poses all of the threats to your domain. Okay, any other time, this would be a polynomial, which is beautiful to work with because they're there's no breaks or problems in the entire domain from negative infinity all the way to positive infinity. But you cannot actually equal 7 and you cannot equal negative 3. Okay, you cannot equal them. So just write your domain as if that's the case. You're going to go all the way from negative infinity all the way to negative 3, but then you're going to have to jump over negative 3 and go all the way to 7, and then you got to jump over the other side to positive from 7 and go to the rest of infinity. Okay, so that's just how it is. Now it doesn't matter if it's a whole or an asymptote. Those are all problems. You can't equal those numbers. Okay, so for example, this negative 3 is a whole and 7 is an asymptote because one canceled out, the other did not. All right, now this is saying find all the vertical and horizontal asymptotes. Okay, now these guys are going to be easy to identify because they both have kind of techniques of like looking at it. The vertical asymptote is found by finding what's going to equal 0 and then doesn't cancel. And then the horizontal asymptote is looking at the powers. Okay, now this guy, you can see here that he has a power of 1 and he has a power of 2. That's the highest power up here, the highest power here. So that is a bottom heavy situation. So this means that the horizontal has to be y equals 0 as a default. Okay, so whenever you're bottom heavy, the horizontal asymptote is always going to be y equals 0. Now the vertical asymptote is a little different. That requires a little bit extra. You don't have to know what 4x equals. This would give you the 0. In fact, we have a 0 at 0 here, but that's not what they asked. In this case, they just want us to know, they want to know what, when you factor this guy, what's going to give you 0. And it looks like they're both, 8, positive 8, and negative 2. Okay, so this means, because these guys do not cancel out, that we have a vertical asymptote at x equals negative 8 and 1 at x equals 2. Okay, now you could have just put x equals negative 8 comma 2. That's totally sufficient. Okay, I know what you're saying. But this does say that those are equations. But then so does this. Okay, it's understood. You labeled it VA. All right. Now this one says we're going to have to use a calculator, so I got my guy ready. Now, using a graphing utility, determine the absolute or relative extrema of the function here. Okay, and then round the answers to 3 decimal places. Okay, well, let's take a look at this guy. Okay, we're going to we might have to play with the window a little bit, but let's go to y equals. We're going to erase whatever's there. And we're going to have x to the 4th and plus 3x to the 3rd and then minus 4x. Okay, let's do a zoom standard so that we're kind of in the middle of things. And then we'll see, okay, that's perfect. Okay, that's everything I needed right there. So now what I got to do is just find the absolute or relative extrema. Now in this case, absolute extrema would be the very most highest value in the entire domain. And since it is not saying that where they clipped off the domain, this guy can go to negative and positive infinity. And these arrows are just going to keep going up. There is no absolute extrema here. There's only relative extrema, okay? In fact, what I see is I see 2 relative minima and then 1 relative maxima. Okay, I see 2 troughs and 1 hill. All right, so I'm going to go ahead and put, going to move this guy out of the way for a second, move this over. Okay, so we're going to say relative, let's do the relative max first. Okay, now relative max is found by going to the second calculate button, and second calculate has a menu of things that you can find. Now we don't need 0, we need a maximum because that's what I wrote there. So let's go max. And then it basically say, okay, well, where do you want the max? Well, the maximum value in between this guy to the left. So it says left bound. I'm going to go to the left of my max. Then it says, okay, well, where's the right? We'll find the maximum value to the right. Hit enter. And what it's got is it's got a window. And it's basically saying, okay, so you want me to find the relative max or in this area? And it says guess. And I'm going to put my guess mark there. Okay, and it says that my relative max is at x equals negative. Now it's at 0.843. Okay, but the max is 2.08. Okay, so there's kind of 2 ways to say it. Right where the location is as far as the x coordinate, and then you can say how high it is by its y coordinate. Okay, so either one is just fine. All right, now we got 2 mins here. So relative mins. Okay, what I'm going to do is I'm just going to write the actual minimum values here. Okay, so let's go ahead and go back to second calc. I go to minimum. Now it's going to find the smallest value in between 2 areas here. I'm going to go here to the right. I'm going to make a guess right there. And it looks like minimum is at x equals -2. And the y equals 0. Okay, so that right here, e to the -12, means that it's so small it's practically 0, which probably means it used calculus to figure this out. Okay, and it got a really good approximation, but it's approximated 0, just like what they did here. Okay, all those decimal places is just because the technique that they used is not perfect. Okay. All right, one more time. Go to calculate. We're going to go to minimum again. And now it's going to ask, I want this side now. That's to the left, to the right. Estimate in the middle, right about there. And x is 0.59. There we go. And the y equals -1.6223. All right, that's it. That's it for the problem. So you see this, just you know it's a calculator skill. All right, find removable discontinuities. Okay, so let's remember what he's called here. That's a hole. And then vertical asymptotes, we know what that is. X-intercepts are zeros. Okay, so we like to just use a hole and zeros because it's just quicker and easier, but that's actually the technical word for both of them. In fact, zeros and hole, that actually is a technical word as well, so no need for that. What we're going to do is we're going to go ahead and factor these guys. I can see that I can take an x out of this guy, and then it's going to be x. Once I take an x out, it's back to a quadratic, so then he will become x squared plus 2x minus 24. So let's see, it's going to be 8 and 3, 6 and 4, so plus 6 and -4. Okay, that's the top. Then in the denominator, I'm going to take a 3x out, and then I'm going to have x minus 4. Okay, so what this does is you don't even have, you can cross these out as just kind of like a reminder that you are going to have, you're going to have a hole here. Okay, so we're going to say the removable discontinuity, okay, is at x equals 4. Okay, then we're going to say the vertical asymptote is at x equals what didn't cancel out right there. That x did not cancel out, so we're going to say at x equals 0. So it's going to have a dotted line right there at 0. And that's it, because the only thing in the denominator is just this 3x and this guy, and since he canceled out, that makes him a hole. But now the zeros are what's left. Oh, cross him out like that. Okay. Wait a minute. Oh, Oh, that was a dumb move. There are none. The x canceled out. Both of these crossed out, so there is no actual vertical asymptote. Okay, so that means that no parentheses left in the bottom. That 3 is not, you're not going to have an asymptote at 3. Okay, now the only 0 that we're going to have is the parentheses that is left over once the others canceled out, because we can't plug in a 0 because we'd be dividing by 0. Can't plug in a 4, we'd get 0 there. So the only 0 that you have is that x equals -6. Okay. All right. So if I plug in a -6, I will get a 0. All right, 0 over 3, which is just 0. All right, that's that guy. So I'm glad I caught that. Ooh, that would have been annoying. All right, let's look at this. Where are we at? 10 minutes? Let's include this one. The cost C in dollars to produce X units of a new Action V video camera for a local distributor is given by this function right here. And X actually has to be greater than or equal to 0. So what do we say when, what is C of 20? Okay, C of 20 represents the cost when 20 units are produced. Okay? Represents the cost when 20 units are produced. You plug in a 20, then you're going to get an output. That output is going to be the cost. Okay? Now you can see here this for x greater than or equal to 0, and that makes sense because you're not going to have negative units. How many cameras can be produced for $20,000? Okay, so what they just did is they gave us the cost. So this means the cost has to equal 85x plus 150, okay? Because what this is saying is that when I plug in a value for x, I'm going to get 20 grand. I need to know that. Okay, so we're going to do a couple quick algebraic steps here. And I'm actually going to use my calculator and say that 20,000 minus 150, because I got to put the 150 over to the other side. It'll become negative. That guy, then I'm going to divide by 85. And it says it's going to cost about $233.53. Oh, no. I'm sorry. That's no. Nope. Okay, we're going to go ahead and round down for this guy. Represents units, okay? So I can make 230. Now, I can't make 234, okay? If I made 234, that would put me over my 20 grand, okay? So that's why I rounded down. So I can produce 233 units, and then when I plug this guy in, he's going to get very close to $20,000, and that's basically how many units I can make. So what does the slope then of this mean? What does 85 mean? Okay, well, it means that I have a starting fee of setting this up for $150, okay? For this is fixed cost, maybe to set up the machine, to buy the machine. And then every time I want a new camera produced, okay, every new camera produced will have an $85 cost to make. Okay? And then if I got 2, of course, then I would multiply 85 by 2, and then that's how much. So every single camera is going to cost me that $85, and then the 150 initial startup. Okay, so that's all that the slope means. That's very important, though. Okay, because that slope represents a rate of change, and that is the whole point of calculus, is to study rates of change. That allows you to have an immensely rich way of solving problems. Problems involving change. The local distributor for that video camera has determined that the number of cameras sold in the week. Oh, you know what? I'm going to stop right there. I'm going to stop there.